Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Anandi, Pune. Today's topic is transfer learning. Now let us discuss first that the outcome of the session. After completion of the session, students or learner able to understand the transfer learning and its application. Learner are able to learn the application of pre-trained model like VGG 16, 18, ResNet and BERT model. The learner able to hands-on on fine-tuning techniques for improved performance. Learner are able to evaluate and optimize the transfer learning model for the better result. Now let us discuss what is the transfer learning. Now whenever data set is not available or only few images are available in our data set, so in this case again there is a problem of overfitting, and it will also affect on your accuracy performance of your model. Now this transfer learning is approach, this is a very uh, famous approach we are using in machine learning and deep learning, in which the knowledge gained through the one task or data set is used to improve the performance of the performance of the or a related task or the different data set. This transfer learning allows application of the pre-trained model to new problems, reducing the data collection and training data. Now let us discuss the transfer learning through this example. Now here there are two examples. Now training from the scratch and the transfer learning, how we are using in this example. Now this is our task. In this example, the task, the problem statement for the task is the vehicle detection. Now in vehicle detection we are using the CNN model, and this model get the best good accuracy in different epoch. Suppose if you train this model for the 95 epoch, then in 20 epochs you will get the 95% accuracy. Now here you can conclude that this model is successfully executed with better accuracy, and you can any input image, test image, you can test over this model, and you can test this image over the, suppose here 10 classes are there, like bicycle, truck, car, tempo, ambulance. These are the different classes are there in this example. Now here this model is successfully executed, and this model trained from the scratch and given the best test accuracy for the unseen images. Now if there is now here next scenario where the vehicle classification example is there, but in this example only two classes are there, that are car and truck. Now in this case no need to create the new design or prepare the new model, CNN model, for the classifying these images. Now already we have one model which is trained from the scratch for the multiple number of vehicles, and here this model is successfully executed. Only you can use this feature, you can use the weight of this model. This is trained on cat and dog or different models, it is already it is trained. Now these feature you can pre-train model you can use for your new task. Okay, and in this case you can also save the time for the training for the huge large data set, and directly you can use the knowledge of the previous trained model. And then in this example, now you can test your model for the new data for the two classes. Now here, what are the significances of the transfer learning? The significance in terms of the data, how we are handling the data, the training time required, the performance of the model, and how we are using the resources for the training and testing purpose. Now the pre-trained model reduce the need for the large annotated data set, as here in pre-trained model we are using the already pre-trained weight of the data set which is trained using pre-trained model. Now reduce training time. The initial layer capture the general feature and reducing the training time. The already extracted feature we are using for your unseen images, so that training time will be reduced. Improved performance. The pre-trained model on diverse data set enhance the performance. And last significance, that is the resource efficiency. If you for the new task, again it requires GPU or CPU system, but already data set is already pre-trained and weights are available. So here this transfer learning allows use of the large and complex model without needing the resource for training. In transfer learning, there are two approaches. One, first approach that is called as the feature extraction, and second approach is called as the fine tuning. We can also combine this approach that is called as the hybrid approach. Now let us discuss first approach that is called as the feature extraction. Now you can utilize this transfer learning by utilizing the pre-trained model layer as a fixed feature extractor. Now in pre-trained model, the CNN extract the feature, and this feature you can use for the other new data set, and also you can add new classifier at the top layer, or you can use the as it is classifier for the new unseen images. In feature extraction, removes the final fully connected layer specific to original task. Add new classifier at the end to the output of the feature extraction layer. The feature extraction approach, which trains the new classifier on the new task data set using extracted feature. Means in your only whatever the feature extracted by the pre-trained model, these features will be freeze, and this feature we can use for the new task and the new data set. Now here this feature extraction trains the new classifier and new task and revision the learning representation from the large data set. Obviously, whenever you are using this feature extraction approach, the already extracted feature you can learn feature use for your new example. Now this is the feature extraction approach example. Now this is the pre-trained model. Now input data and labels are given. The images will be passed through the different convolution blocks, and then in fully connected layer only this part will be frozen by the CNN model in pre-trained, and this part we are utilizing in our new task. This is our pre-trained model. Only these features will be frozen, and this feature weights are extractor will be frozen, and here you can add your own new data set, or you can text with the unseen images, and new classifier layer you can add in feature extraction approach. Now next, one more approach that is called as the fine tuning approach. Now a specific form of transfer learning which involve taking a pre-trained model and continuing the training process on new and typical smaller data set. Now let us discuss this is in this example. Now this is the ImageNet data set, large public data set, ImageNet data set. Already this is this data set is trained using pre-trained using any CNN model, and here this model is successfully executed, and the images will be classified against these classes. Suppose this is the ImageNet data set. Whenever you are using pre-trained model, now these images predicted over 1000 classes. Okay, now this brown part, it represents the image feature, and this blue color indicates the fully connected layer and output layer or classifier layer in pre-trained model. Now this model, in using fine tuning approach, we are here we are implementing our task where the new image small data set is given. These are the diabetics retinopathy images. Using these images, we can extract with this image data set, we can train these images using pre-trained model. Already this pre-trained model is utilized. In fine tuning approach, what happened, we can update the layers in neural network. Also you can update the features layers, and then accordingly you can fine tune this pre-trained model to improve the result of the model, and then you can add the classifier layer, and here you can change the number of classes. Now here this image, now this model is trained for the dog, cat, car, for this all images. Only using this knowledge of the pre-trained model, we are updating the number of layers in a model, and that is called concept is called as fine tuning. Fine tuning means we are fine tuning the layers in a pre-trained model. In feature extraction model, we are using the features of the images, or you can test the unseen image over the 1000 classes of ImageNet. Now let us discuss the difference between feature based and fine tuning approach. As in this example you can see, in this diagram you can see, now this is the fine tune approach, this is the feature based approach and this is the fine tune approach. Now here in fine tune approach what happened, the pre-trained features model we are using and hold the features of the images. You can also complete the prediction over the 1000 classes of the ImageNet. Okay, on another option you can hold these features, and for this feature you can add other classifier, means we are removing the top layer and adding the another classifier. This is the feature based approach, whereas in fine tune approach you can perform the prediction for the unseen image. Also you can replicate this model up, perform some changes in the layers of the pre-trained model, fine tune the model to improve the accuracy of your pre-trained model for the new data set and new task. Here with respect to with different aspect you can see the difference between fine tune and feature extraction model. Already in previous example we have discussed, and again we'll revise the difference between fine tune and feature extraction approach. Now first layer adjustment. Now in fine tuning approach we are unfreezing some of layer and layers for the some or all layers for the training. In feature extraction freeze all layer except the new classifier. In fine tuning approach the output layer replace and train for the output layer, whereas the in feature extraction replace and train the output layer. In fine tuning approach the training scope, that is the training we are training the complete uh, model or partial model you can retrain. Only new classifier will be trained in with feature extraction approach. Next aspect, that is adaptation level. uh, in fine tuning approach this adaptation level is high as the model can learn new task specific feature. Now here the adaptation level for the feature extraction approach is moderate because it uses the general features from the pre-trained model. Computation with aspect of computational cost, the cost is more for the fine tuning because it is updating more parameters, as it is adding the more layers or removing updating layers in a pre-trained model. uh, the computational cost is very low in for feature extraction approach because it is considering only, we are only considering only features of the images, so only and all these features will be frozen, and so fewer parameters are there for the training purpose. For the suitability aspect, the fine tuning for similar tasks with the sufficient new data, whereas for feature extraction for different tasks or when computational resources are limited. There is a risk of overfitting in extraction, in fine tuning, because very changes we are updating in layers as well as the feature layer. So with new, whenever we are using the new data set, there is a risk of overfitting. There is a less overfitting risk in a feature extraction approach, as the pre-trained weights are not updated, as it is weights we are using for the new data set or new task. The use cases for fine tuning, that complex tasks with the significant domain shift, whereas the simple task when the domain shift is minimal, at that time we can prefer feature extraction. This is all about how we are using the transfer learning in deep learning with two approaches that are fine tune and feature extraction. Thank you.